Hey everybody, Mr. Tannen here. I just made a video for 29, but I'm going to also make a video for 28, which somebody had asked me about. So I'm going to get working over here on my OneNote. So this is telling us, let's suppose that a function has a continuous second derivative for all x. That's good, so it means it's continuous and differentiable, and they give us f of 0, f prime of 0, and f double prime of 0, and g be a function whose derivative is given by, it's really hard to see, but that's actually g prime of x, I think. Yeah, is this e function times this 3 times the function of x plus 2 times the derivative of f for all x. So first they're asking us to write the equation of the tangent line. So remember, point slope. Well, the point is actually given to us quite nicely of f. The point, they say f of 0 is 2, so that's the point 0, comma 2. And the slope, they already told us, f prime of 0 is negative 3. So then I just put it y minus the y value, which is 2, is equal to the slope, which is negative 3 times x minus the x value, which is, I guess, just 0. So it could just be y minus 2 equals, I guess I could write it in my formal form if folks prefer. But that really, I guess, is just negative 3x plus 2. Not sure if we'll need this again later, if I distribute that negative 3 and add the 2 over. Is there sufficient information to determine whether or not the graph of f has a point of inflection when x equals 0? Explain your answer. So let's think about this. Well, we know f double prime of 0 is 0, but are they telling us anything else about f double prime? We know that it also has to change sign, so I'm going to say no. We don't even know what f is, because we do not know that f double prime of x changes signs. Okay, we're cooking with gas now. So given that g of 0 is 4, write an equation of the line tangent to the graph of g at the point where x equals 0. Okay, let's do that again. Point, slope. Oh, this is kind of a fun one. So the point is 0, comma 4, from g of 0 being 4. So we actually, I think, oh, we have g prime, so we just need to plug in 0 there. Let me go over here to write this out. I'll write out my function first. So g prime of x is e to the negative 2x times 3 times f of x plus 2 times f prime of x. Okay, well this is not too bad, because g prime of 0 then would just be e to the negative 2 times 0 times 3 times f of 0 plus 2 times f prime of 0. And we actually have all this information. F of 0 is 2. F prime of 0 is negative 3. Some ice just fell next to my head. It kind of scared me. And anything to the 0 power is just 1. So that's very nice. So I just get 6 minus 6. Are you for serious? Is that right? 1 times 0 is just 0. So g prime of 0 is 0? Is that for real? Okay, well, so the slope is 0. So it'd just be y minus the y value, which is 4, equals the slope times x minus the x value, which is 0. So I guess it's just, the right side is just becomes y minus 4 equals 0. So if I add the 4 over, it's actually a horizontal tangent line, the line y equals 4. That's my answer. Okay, we're doing pretty good now. So, they say show that g double prime of x is equal to that. So I can take what I already have here. I guess I'm going to have to derive this second time. Slide this bad boy down here to work with again. So does g have a local maximum at x equals 0? So we want to see if the slope goes from positive to negative at x value of 0, because if oh, no, that would be if g prime. We want to see if g double prime is negative. If it's concave down, then we know it has a maximum, because we've already okay, I guess we have to also show, oh, we already found that g prime of 0 is 0, so we know it satisfies, that's the second derivative test. We know the slope is 0, so if it's also concave down, then the second derivative test tells us that it has a maximum. That's what this is referencing. So let's take the second derivative. So left, product rule, left d right, that's just 3 f prime of x plus 2 f double prime of x, because the derivative of the derivative is the second derivative, plus right, so just take the right part as it is, d left. Well, the derivative of this requires the chain rule, so it's just negative 2e to the negative 2x. Alrighty, so let's see. It looks like it's just an e to the 2x here, so what I imagine is, since it's all product, we should just distribute the 2x in there. So that's going to be a negative 6f of x minus a 4, I just switched the sign, f prime of x. And now I just have the, because I got the, so it sort of becomes just algebraic manipulation here. So now instead I could, since these are both have an e to the negative 2x, I could just combine my terms. So it's e to the negative 2x times all of these parts together. So 3f prime minus 4f prime. Well, look, let me do my f of x's first. So I got there's only one set of f of x's. Cross it out. Now let's do my f primes. 3 minus 4 is just minus 1 f prime of x. Cross those out. And then I only have one set of terms of f double prime of x. And that's nice because I just showed that, I guess I should have wrote the second derivative here, and then I'm just bringing it down. So I showed that the second derivative is exactly equal to what they wanted it to be equal to. Okay, so now does g have a second derivative? Well, now we're going to go back up here, because when we want to see if g double prime of 0 is negative, we hope it is. Well, I guess we don't really hope one way or the other, but it would show it does have a local maximum. So let's plug in that 0, e to the negative 2 times 0. You might say, why not just make it 1? Just trying to show everything quite nicely. You know how I like to do it. We got plenty of time. We're coming well in under our 15-minute required time. Really cooking with gas, feeling proud of ourselves. Way to go, team. Okay, check this out. So f of 0 we already said is 2, so that becomes negative 12. F prime of 0 is negative 3, so minus negative 3 becomes plus 3. And f double prime of 0 is 0, so that's just 0. This is all just 1. So look at this. I just get negative 9 times 1, which is negative 9. So yes, since g double prime of 0 is a negative, and g prime of 0, we already found up here, g prime of 0 equals 0 by the second derivative test. g of x has a local maximum at x equals 0. That's a perfect justification for our answer, and now we're good to go. Nice work on this one. Again, we saved about 5 minutes, so we could take some time to check over our work. Feel pretty good about everything, but if we look it over, it's really just this one down here. I wrote some of it over here. I think we're pretty good. We could take a minute to look it over and still have some saved time. Have a great day. Tannen out.